We're also going to be talking about polar form, and polar form is often used in navigation and direction of travel. To turn it into polar form, what we actually want to do is rename these sides, the legs of the triangle. We can get the length of this side by, if you guys remember from trig, cosine of theta, which is the angle, is equal to adjacent over hypotenuse. And let's call this hypotenuse r instead of the absolute value of a plus bi. So this would be adjacent over r. If we solve for the adjacent side, then this is just r times cosine of theta. And similarly, we can do something for this side. This would be r times sine of theta. So a is equal to r times cosine of theta, and b is equal to r times sine of theta. So if we add a plus bi, we would actually get r times cosine theta plus I sine of theta, if you factor out an r. So this part over here is called the complex form, and this is called the polar form. Since we're given a and b, b is our opposite side and a is our adjacent side. Opposite over adjacent, that's tangent. So if we wanted to find the angle, we can do our opposite, which is b, over adjacent, which is a, and then solve for that angle in that way. Because remember, to get the angle by itself, you can take the tangent inverse of b over a. And this would give you the angle of the inside. So if we wanted to convert this complex number into polar form, there are two things we need. We need to figure out what r is, and remember that that's just the absolute value. So that was a squared plus b squared. And we also need to figure out what our angle theta is. And as we just said, our theta, our angle, we can get by taking the tangent inverse of b over a. So let's try to figure both of these out. So from looking at this form, we can tell that a is this first number, which is 2, and b is the coefficient of I, which is 3. So we can just plug this all into our information. So r would be equal to the square root of 2 squared plus 3 squared. And that is just the square root of 4 plus 9. 4 plus 9 is the square root of 13. So r is equal to the square root of 13. That's one piece of information. Now let's figure out theta. Theta is the tangent inverse of b, which is 3, over 2, which is a. So we can use our calculators for this and make sure that it is in degree mode. So you can plug in tangent inverse of 3 over 2. And we get that theta is approximately equal to 56.3 degrees. So if we substitute this information back into the polar form, we would get the square root of 13, because that's our r, times cosine of 56.3 plus I times sine of 56.3. This would be our polar form. So let's try another one. If we wanted to turn negative 2 minus 2 square root of 3i into polar form, we again have to look for r, which we said was the square root of a squared plus b squared, and we again have to look for our theta, which was the tangent inverse of b over a. So let's identify what our b and a are. Our a is negative 2, and our b is the coefficient that's in front of I, which is negative 2 square root of 3. So now let's plug this into our information. To get r, a squared, that's going to be negative 2 squared plus our b squared, which is negative 2 square root of 3 squared. Negative 2 squared is 4 plus negative 2 squared. To square something like this, you first have to square the negative 2, and then you also have to square the square root of 3. So negative 2 squared is 4 times, the operation was multiplication, so we're multiplying by the square root of 3 squared, that is 3. So we have this, 4 plus 4 times 3. This would just be 4 plus 4 times 3 is 12. And 4 plus 12 is just 16. So this is the square root of 16. So the square root of 16 is 4. So this is what we get for r. Now let's do our angle. Our angle is going to be equal to the tangent inverse of our b. Our b we said was -2 square root of 3 over -2. If we simplify this, we can actually cancel out the -2's. So this is going to be equal to the tangent inverse of the square root of 3. Again, we can either plug this into our calculator, or if you know what it is, you can use that too. This is actually equal to 60 degrees. So this is what our theta is, and we know that this is our r. So now all we have to do is just plug this into our polar form. So -2 minus 2 square root of 3i is equal to r, which is 4, times cosine theta, our theta was 60, plus I sine of 60. And this is what our polar form would be. So just like you can turn complex numbers into polar form, you can also turn polar form into complex numbers. And I'll be showing you guys how to do that next.